Hello and welcome to lesson 2J. I can prove angles congruent or supplementary giving parallel lines, and I can use theorems about congruent or supplementary angles to prove lines parallel. So we are basically going to be applying all of the new proofs and theorems we proved last class to new diagrams. And I just want to start off first by going through and basically showing you how you can use information to prove lines parallel or angles congruent or supplementary. So for example, if I'm given that angle 1 is congruent to angle 5, angle 1 is congruent to angle 5, I know that those are alternate exterior angles. And we proved last time that if alternate exterior angles are congruent, then their lines are parallel by the alternate exterior angle theorem, okay? Because we're proving the lines parallel, that means we use the regular version of the proof, not the converse. Whereas in number 2, if I'm given that C is parallel to D, and what allows me to prove that 5 is supplementary to 12? Well, angle 5 is here, angle 12 is here. Those are consecutive interior angles, and because we're proving the angles to be supplementary, we're going to use the converse of the proof. So that's the converse of the same side interior angle theorem. Well, if let's just keep going through these. If I know that 2 is supplementary to 15, here's 2, here's 15, those are same side exterior angles, so I'm able to prove A parallel to B by the same side exterior. And notice we use the regular version, not the converse, because we're proving the lines parallel. If I'm trying to prove 10 congruent to 11, or sorry, 10 congruent to 12, those are corresponding angles. And if I'm given that they're congruent, then I'm able to prove, if corresponding angles are congruent, that their boundary lines, A is parallel to line B, the other boundary line, by the corresponding angles postulated. Whereas if I'm given that A is parallel to B, I can prove angle 11 is congruent to angle 15. Well, those are alternate interior angles, so I can prove that by the converse of the alternate interior angles theorem. If angle 6 is congruent to angle 12, those are alternate interior angles with boundary lines C and D. So that actually allows me to prove that C is parallel to D by the alternate interior angles. Whereas if 8 is supplementary to 9, those are same side interior angles with boundary lines C and D. So that allows me to prove that C is parallel to D by the same side interior angle. And if angle 16 is supplementary to angle 13, well, now my boundary lines are A and B, so I can prove that A is parallel to B because angle 16 and angle 13 are same side exterior angles. So I'm able to prove that A is parallel to B by the same side exterior. And last but not least, if I'm given that A is parallel to B, I can prove that 5 is congruent to 13. Well, those are corresponding angles, and because I'm given that the lines are parallel, I can prove that by the converse of the corresponding angles. Now, there's one last thing I want to talk about before we move on to harder problems. I want you to notice that we only use the converse when we're proving something about the angles themselves, right? So I use converse when I'm proving things to be congruent or supplementary. We use the regular version whenever we're proving lines to be parallel. Okay, so that's a really that's a distinction you definitely need to make. When to use the converse and when do you use the original. So let's move on and look at some harder proofs now. So we've talked about how to do basically up here, guys. These were all basically one-step proofs, right? Given that I can prove something congruent with one step. Now we're going to look at some things that require a bit more work. If I know that A is parallel to B and C is parallel to D, I want to now prove angle 7 congruent to angle 11. When you look at these guys, you can see there isn't a vocab word that describes their relationship, so it's not a one-step proof. I'm going to need to do a lot more work in order to prove this. Now, the best way to do these is to find a helper angle, and a good helper angle has a defined relationship with both of the given angles. I'm going to use, in this case, angle 5, because angle 5 corresponds with angle 7, which will make them congruent, right? And it's alternate interior with angle 11, which will also make them congruent. So that will allow me to use the transitive property to eventually set 7 congruent to 11. So let's walk through our proof. We always set up the same way, by making our T-chart, doing statement reason, and listing my givens. Now, my next 2 steps, I'm going to describe how my helper angle relates to the 2 other angles I've chosen here. And so I do just that. Angle 7 is congruent to angle 5 by the converse of the corresponding angles postulate, and angle 5 is congruent to angle 11 by the converse of the alternate interior angles theorem. Now notice I'm using the converse at this point because what's over here is something to do with the relationship of the angles, not to do with whether or not the lines are parallel. So that's when I use the converse. Now that I have gone through and shown 7 is congruent to 5 and 5 is congruent to 11, now I can use the transitive property to show that angle 7 is congruent to angle 11 by transitive property of congruence. And guys, that's what I was trying to prove. So I'm done. That's it. Lovely 4-step proof. Not too bad. So let's now take a look at one that's maybe a little bit more involved. Now I've got the same givens, A parallel to B, C parallel to D, but now I'm trying to prove that 16 is supplementary to 3. Well, here's 16 and here's 3. Notice again, they're not in the same, they're not surrounding the same boundary lines, and so we don't have a good vocab word for those. They do not have a given relationship. So what I want to do, just like before, is I want to choose a helper angle. And my helper angle needs to have a good relationship with both of the angles. If I choose angle 1, I like it because it corresponds with angle 3, and it's same side exterior with angle 16. So it's got a good relationship with both angles, so that's what I'm going to do. And we go ahead and we start our proof the same way we always do. We start off by listing statement and reason in a T-chart, and we list our givens. That's our good basic structure. Now my next 2 steps, I'm going to talk about how angle 1 relates to both angle 3 and angle 16. Well, angle 1 is congruent to angle 3 by the converse of the corresponding angles postulate, and angle 1 is supplementary to angle 16 by the converse of the same side exterior angle theorem. So that's how our helper angle is related to both. Now I'm going to interpret both of these in my next 2 lines by looking at what it means to be supplementary. Well, it means you add to be 180. And so angle 1 plus angle 16 equals 180 degrees by the definition of supplementary. And then I'm now dealing in the world of equal signs. So I'm going to have to do a conversion step to say that angle 1, the measure of angle 1 equals measure by the definition of congruency. And now that I've done that, I'm able to make a substitution, right? I've got an angle 1 here, and I know that angle 1 is the same as angle 13. So my next step, 6, I'm able to say that the measure of angle 13 plus the measure of angle 16 equals what? Not 13, it should be 3. I'm sorry, guys. Measure of angle 3, don't know where the 13 came from, plus the measure of angle 16 equals 180 degrees by substitution, property of equality. And I'm trying to prove that 16 is supplementary to 3, which means I need to end with this exact statement. Well, what I just wrote here basically is the definition of what it means to be supplementary. So now I can say that angle 16 is supplementary to angle 3 in step 7 by the definition of supplementary. And we're done with our proof. All right, guys, let's go ahead and look at the next one. Now we're doing something different. We're going to start with some congruency laws, and we're going to prove lines to be parallel. And guys, we're going to add something to this proof. We're also going to prove C is parallel to D. We're going to do both, okay? So taking a look at this, I've got angle 1 is congruent to angle 11, and I've got that angle 4 is congruent to angle 12. Well, I know that 4 and 12, these guys are corresponding angles. So that will allow me to prove C is parallel to D immediately because I've got some congruent corresponding angles. Now with my other two, I need a helper angle to help us establish how they relate to each other. And my helper angle needs to have a good relationship with both of them. And I'm going to make angle 9 my helper angle in this case because it happens to be a corresponding angle with both angle 1 and angle 11. But let's go ahead and set up for our proof. So we've got our good setup, and now the first thing I want to do is go ahead and use the thing you're given to make some lines parallel, because I really can't do anything until I have a pair of parallel lines. Well, if 4 is congruent to 12, they're corresponding angles, so C must be by the corresponding angle postulate. Notice, this is not the converse. It's not the converse. And because it's not the converse, it's just the regular version, that's because we are proving a line to be parallel in this step. So we don't need to write the converse on this one. Well, now that I've got C parallel to D, I'm going to look at this helper angle, and I'm going to ask myself, which of these two relationships can I go ahead and discuss if I know that C is parallel to D? Well, if I know that C is parallel to D, then I can talk about anything that has a vertical relationship going up and down. So I'm going to go ahead and talk about angle 1 and angle 9 in my next step. And angle 1 is congruent to angle 9 by the converse of the corresponding angles postulate. Again, guys, notice I'm now using the word converse because on this side, I'm talking about relationships between angles, not between lines. Well, now that I've done that, I already know that 1 is congruent to 11, and we know 1 is congruent to 9. So by the transitive property, I can say that angle 11 is congruent to angle 9. And again, guys, that's by the transitive property, not by the corresponding or converse of the corresponding angles postulate. I cannot use the corresponding angles postulate going horizontally yet because we haven't proven A parallel to B. That's what I'm trying to do, but I haven't gotten there yet. Well, now that I've proven angle 11 is congruent to angle 9, those are corresponding angles that I've now proven to be congruent. Now I can say that A is parallel to B by the corresponding angles postulate. Okay, and again, it's the regular version, not the converse, because we are talking about parallel lines. That's why I'm able to use the regular as opposed to congruent or supplementary angles. So that's the end of our proof. We can put a little box and color it in. All right, guys, moving right along, let's take a look at this proof. It's a little bit more involved because we've got supplementary things happening in it. I'm given that angle 8 and angle 13 add to 180 degrees. Well, they don't have a good relationship, so I can't really start with them. That doesn't help me. But I'm also given that 5 is congruent to 11. Now, 5 and 11 are alternate interior angles. So if I know that those are parallel, I can prove that their boundary lines, C and D, are parallel. So my first step is going to be to prove, or rather my second step after the givens, is going to be to prove that C is parallel to D by the alternate interior angle theorem. Now I'm going to need a helper angle to help me get A parallel to B that involves the other pair of angles I'm given, this 8 and this 13. I want to choose a helper angle that has a relationship with both of them. I'm liking 16 because 16 corresponds with 8 and is a same side exterior angle with 13. So that's why 16 is a good helper angle. So that's my plan. I'm going to work with alternate interior angles and do the stuff in green first, and then I'm going to use the stuff in blue to prove A parallel to B. So let's go ahead and get started. So we start out by listing our givens, and guys, I'm color coding this so you can see how I'm doing this in 2 big chunks. Well, I've been able to prove that I already know that 5 is congruent to 11. And because 5 is congruent to 11, that means their boundary lines are parallel. So C is parallel to D by the alternate interior angle theorem. So I've proven a pair of lines parallel. Now I'm going to switch on to work on the stuff in blue. I always start with, if I'm able to prove that C is parallel to D, that means I'm able to work vertically in this problem. I can't work horizontally yet because I don't know if A is parallel to B yet. That's what I'm trying to prove. So I'm going to start off by looking at my vertical relationship first between angle 8 and angle 16. And I'm able to say that angle 8 is congruent to angle 16 by the converse of the corresponding angles theorem. So we're happy there. Well, now I want to force a relationship between 16 and 13. That's my goal. So if you notice, I've got 8 related to 13 up here with an addition to 180, some supplementary angles. So I'm going to flip this guy now into equal signs with my definition of congruency so that I can make some kind of substitution and say 8, well, 8 is the same thing as 16. I'm going to sub 16 into my next step to get a relationship between the 16 and the 13. That's the thing I'm trying to force right now. So I'm able to make that substitution and say that the measure of angle 16 plus the measure of angle 13 equals 180 degrees by the substitution property of equality. Well, now I've got that 16 plus 13 equals 180. Well, that's basically saying that they are. And so if 16 is supplementary to 13, I can say that line A is parallel to line B because we have a pair of supplementary consecutive exterior angles. So my last step, I can prove A parallel to B by the same side exterior angle theorem. And we're done. We did it. We proved both pairs of lines parallel. All right, guys, this practice is on the longer side, but that's because it's kind of a more involved knowledge check. And if you can do these kinds of parallel line proofs, you understand parallel lines. So I want you to go through. There is a key posted online under the topics page. Go through and work through all of these different problems. I want you to notice, I want you to be very attentive to when you use the word converse versus when you don't, right? I want you to pay really close attention to strategies. So choosing helper angles, proving lines parallel whenever you can, so go ahead and do the practice assignment and then the knowledge check. Thank you so much.